Welcome. I have at the top of the page here a summary of how to create a modified box plot. So just reviewing the process that we have done with our Roger Maris baseball example, and I'll just jump in here and do another problem for you. So you've got all the information there at the top, but let's dive into this question. Okay, so we have 15 quiz scores. Check the data for outliers. And when we have outliers and identify them graphically on a box plot, it's called a modified box plot. So we'll skip the regular one and go right to modified to see if there are outliers in this data set. All right, so I did put the values in ascending order to make things easier. And there are 15 quiz scores, so an odd number. So I'm actually just going to take 15, divide that by 2. So 7.5. So if I count 1, 2, 3, 4, 5, 6, 7, that value 14 will be in the middle of that data set. So that is my Q2 or my median, because there's 7 numbers to the left of it and 7 numbers to the right of it. All right, and then to find Q1, I'll go to the middle of those 7 numbers to the left of it, and that would be at 13. So that's our Q1. And then our Q3, the middle of these 6 numbers to the right of Q2, that will be at 17. So there's our Q3. All right, so Q1, 13, Q2, 14, and Q3 is 17. So I'm not worrying about the minimum and maximum because they might be outliers. And so we're going to check for that next. All right, so we'll need the IQR. So IQR is the difference between Q3 and Q1. So in this case, 17 minus 13 is 4. All right, and then we're going to find our boundaries. So I'm going to abbreviate lower bound, upper bound. And when I write the formulas, I just go in this order to remind myself lower bound is going to be Q1, upper bound is going to be Q3. And for lower bound, I subtract. For upper boundary, I add. And the amount I add and subtract is 1.5 times our IQR. So my Q1 is 13 and my Q3 is 17. I just like to do that first so I don't make any mistakes. That helps me out. And then 1.5 times our IQR is 4. All right. And then I'm going to enter those just like I wrote them on paper. I'll let the calculator take care of order of operations properly. I get a lower boundary of 7 and an upper boundary of 23. All right, so these are not quiz scores. We have the quiz scores. These are the data that we'd like to graph, and we're going to check to see if any of those quiz scores are outliers. So let's start with our lower boundary of 7. So on a number line here, that's 1, 4, 12. So 7 would be between the 4 and the 12. So that's our lower boundary. So that's a 7. And then our upper boundary is 23. So if that's 19, 23 is somewhere past that. So that's our upper boundary. Okay, and then we're ready to identify our outliers, if any are present. So let's go to our low end here. So the quiz score of 1 and a quiz score of 4 are below the lower boundary. So both of these students would be considered outlier quiz scores compared to the other students. So 1 and 4 are both outliers. And let me talk about the whisker then. So when we graph our whiskers, the lower whisker, the left whisker, usually goes down to the smallest number in the data set. But 1 and 4 are now excluded because they're outliers. So the new lowest number is 12. So I'm just going to circle that one. That'll be our whisker. And then on the higher end here, no students scored above the upper boundary. So we don't have any outliers on the high end. So the highest number in the data set is the 19. Okay, so our outliers, if there are any, so there don't have to be outliers in the data set, but in this case, 1 and 4. All right, so they're outliers 1 and 4 because they are below the lower boundary. So my left whisker, we decided here, ends at 12. My right whisker ends at 19. And then I'm ready to draw my graph. So I like to do my box first. So Q1 is at 13. Q3 is at 17. So that's my box. We always hover these boxes above our x-axis here. These axis values are our quiz scores. So we don't want to write over this. We want it to be clear what these numbers are. So we put our box above the number line. And then Q2, 14. So in this case, that will be there. And then I'll do my left whisker next. That's 12. So short whisker there. And the right whisker ends at 19. And then my outliers, my special symbols there, quiz score of 1 is an outlier. So my 1 there is my outlier. And then I also have 4 as a quiz score, that's an outlier. So the student that got a 1, the student that got a 4 are doing quite below the rest of the class here in terms of quiz scores. All right, so this is a modified box plot. When we talk about the shape of the graph, we often don't even consider outliers. So shape, we would usually just consider the actual box and whisker here. So that graph would be skewed to the right again. So right whisker longer than left, right side of the box longer than the left side. So histogram-wise, it would kind of look like that. So we don't always discuss shape, but just to review here, that would be skewed right. So we don't really think about outliers in terms of looking at the graph of the distribution of the students that are not in this unusual group that are outliers. Okay, and then if you wanted to graph it on your graphing calculator, you could certainly do this one that way as well. And the only other thing I wanted to point out is that if you feel like you have any trouble finding Q1, Q2, Q3 by separating the values into 4 parts, you can always just use 1-bar stats. You could put the data in L1 and just do 1-bar stats. So there's different ways that you can find your quartiles. And then the last thing I'll point out is that even though there were outliers, we don't reevaluate the quartiles. So those just always remain the same. And then we create our graph from there.